Hello, everybody. It's Mrs. Pound, and we have been studying Chapter 5 on electron arrangement from BJU Chemistry's 5th edition. Today, we're going to focus on the second part of Section 5.3 on electron dot notation, and this is the last thing we're going to talk about in this chapter, so you should be getting ready to take a test. So our objectives today are to identify valence electrons in an atom, depict electron dot notation, and determine types of ions and their charges. So first we need to talk about valence electrons. These are the electrons in the outermost energy level of an atom that are the ones most likely to be involved in chemical bonding. They are not necessarily always the last electrons to fill an orbital, and they occupy the highest numbered S and P sublevels. So when we talk about valence electrons, we're going to focus on the S and P blocks of the periodic table. So the very left and the very right parts of the periodic table. We will not be talking about the D and F blocks, which are in the middle. And we're going to take a look at electron dot notation, which is a shorthand way of showing valence electrons. So the first thing we're going to take a look at is group 1. Group 1 has one valence electron. So you can see here lithium group 1. And for the electron dot notation, we just put a dot to the left of the chemical symbol, and that represents one valence electron. And the left-hand side of the symbol represents the s orbitals. So here we have one valence electron in that very first s orbital. Let's switch over to our periodic table. The group 1, all of these have one valence electron, and so you will just put a dot to the left of them to represent that electron. And it's easy to remember group 1, one valence electron. Group 2 has two valence electrons, and we're going across that second period, that second row. And so here is beryllium, and because I said the s orbitals fill up, just like when we did our orbital notation, we fill up that s orbital first before we start in on the p's, and so we put two dots to the left of the symbol to represent those two valence electrons in the s orbital. So over here, group 2, two valence electrons, and all of these will have two electrons, two dots to the left of the symbol for the electron dot notation. So that's the S block, okay? Now we're going to skip over to the P block. So we skip to group 13, and the rule for these is just cover up the 1, and there are three valence electrons. So we look at the second number to determine the valence electrons for group 13 through 18. And here we have boron. Okay, so the first two electrons go in that s orbital, and then the p orbitals are going to be at the top, to the right, and the bottom. And so we start by just putting one electron, just like in our orbital notation. We put one dot above the boron to represent that first p electron, that first p orbital electron. So over here, group 13, we just take off the 1, three valence electrons. All of these will have that same electron dot notation. Group 14, four valence electrons. Just look at that last number. So carbon, so the two s orbital electrons, and then we put a dot to the top and a dot to the right for the p orbital electrons. So here, group 14 with carbon at the top, all of these will have that same electron dot notation. That's the group I'm talking about. Group 15, five valence electrons. Remember, just look at that last number. Ignore the 1. So nitrogen. Nitrogen has those two s electrons, and then it has three p electrons. And remember, we fill one orbital at a time, and so we have one at the top, one off to the side, and one at the bottom. Just very similar to our orbital notation. So here, group 15, all of those have the same electron dot notation. because we're just focusing on those valence electrons. Group 16, 6 valence electrons. Again, just looking at that last number. So the way we do this is these are our S electrons that we've already filled in. Then because we already have, we put a dot, for the p orbitals, 1, 2, 3, we have to go back up to the top for 4 so that we have a total of 6, because we're going to, just like our orbital notation, go back and pair these up. Remember, they're just single electrons, and we fill in the p orbitals with 1 electron, and then we go back and we pair them up with the opposite spin electron. So group 16 here with oxygen at the top, all of these will have the same electron dot notation because they all have 6 valence electrons. Group 17, 7 valence electrons, just looking at that last number. And again, these are our S's that we fill in, then 1, 2, 3, 4, 5. Oh, excuse me. 1, 2, 3, 4, 5. Yes. 5 electrons after that, so we have just one that is unpaired. And where these are handy is this shows us where there are unpaired electrons that can bond, because we're going to be using this for bonding later. So group 17 here, 7 valence electrons, all of these have the same electron dot notation. And finally, I'll just do this fast here. Group 18, how many valence electrons do you think? If you said 8, you're correct because we just look at that second number. So let's take a look at how we treat that. So group 18, 8 valence electrons. We have neon here, and just 2 electrons on each side for the 8. And they're called noble gases. These are very happy elements because 8 electrons around it make it very stable. In fact, that is what elements are, or atoms are after, is that stability of 8 electrons. So sometimes because they become ions in order to achieve that. And so an ion is an atom or group of atoms with a non-zero charge. There are 2 types. There's a cation. This is an atom with a positive charge. It loses electrons, and an example is beryllium. Beryllium will lose 2 electrons to have a positive 2 charge. Now, notice here, it has a 2 plus is how we write that. We don't write it plus 2, we write 2 positive. That's the convention. We put it in these brackets to show that it is an ion. And now it actually has a noble gas configuration. So it is very stable. It is very happy. And what happens is elements that have say 2 or 3 valence electrons tend to lose electrons because it's easier to lose them to gain them at that point. They tend to lose them to gain that noble gas configuration. So, 1, 2, 3 valence electrons, chances are they're going to lose them. Anions, on the other hand, are atoms with a negative charge. So A usually means not negative. There's also an N there for negative. Cation, notice it has a T for positive, so that might be a way to help you remember what these become. So cat has a T for positive. Anion has an N here for negative, and A in front of a word means like negative, not. So atoms with a negative charge, they gain electrons to become negative. So an example would be fluorine gaining an electron. So we add it to its electron dot notation, and we add a negative charge up here. And so now it has that noble gas configuration that is very stable that it is after. So we're going to be discussing bonding in future chapters, and that is why atoms bond, is because it makes them more stable. They're getting a noble gas configuration of 8 valence electrons. So our objectives today were to identify valence electrons in an atom, depict electron dot notation, and determine types of anions and their charges, or ions and their charges. So don't forget your 5 questions in your margin and be starting to study for your test.